All right, so let's take a look at 5 through 10, looking at zeros and their multiplicities. In this unit, we call solutions zeros. And multiplicities is how many times does that solution appear. So just a quick example that I like to show. If I did, in parentheses, x minus 2 squared, well, we should expect to see two solutions because we have a squared x. But if we graph this, we hit the x-axis once. And where we hit the x-axis are the solutions. And this makes sense because if we took x minus 2 squared and set it equal to 0, well, that's like x minus 2 times x minus 2 equals 0. And we would set both of these factors equal to 0. And we would get x equals 2 twice. And so on a graph, you can tell what the multiplicity is, because if it's an odd multiplicity, it goes through the x-axis. If it's an even multiplicity, it hits the x-axis and bounces off. You'll see the word bounces or touches. It doesn't cross the x-axis, it just bounces once it gets to 2 and comes back up. Versus x minus 2, oh boy, well, x minus 2 cubed. Now we should cross at x equals 2. And we do. The graph comes up to x equals 2, and it goes through it. We could zoom in to see that it's crossing exactly at 2. And why don't we? Let's go to 0 and 5. There we go. It kind of flattens out as it gets close to the x-axis. And again, we could zoom in infinitely close to see some more separation there. But it's crossing the axis at 2. So an odd multiplicity crosses, an even multiplicity touches at that solution. So let's take a look at these. These we don't really need the graph for. We can solve these. So on number 5, we have 4 terms, and we'll be able to factor using the grouping method. On the left, I can factor out an x squared. So x cubed divided by x squared is x. 4x squared divided by x squared is 4. So hopefully we get x plus 4 over here. Always bring down this sign. I have a coefficient of 9, and 36 is divisible by 9. So we're going to factor out a 9. Well, a negative 9. Negative 9x divided by negative 9 is just x. Negative 36 divided by negative 9 is positive 4. So those matched, and that's great. So we have x squared minus 9 times x plus 4. But x squared minus 9 we recognize as a difference of squares. That's x plus 3 times x minus 3. Bring this down, x plus 4. And this is set equal to 0. We set equal to 0 to solve. So we had an x cubed, so we would expect 3 solutions if they each have a multiplicity of 1. And in this case they will, because these are 3 different factors. That's positive 3 and negative 3. So by now we probably don't need to write down like x plus 3 equals 0 and subtract 3. If we have x plus 3 as a factor, then x equals negative 3. If x minus 3 is a factor, that solution is positive 3. And if x plus 4 is a factor, then the solution is x equals negative 4. So our solution set is, and it doesn't matter what order these are in, negative 4, negative 3, positive 3 in the braces here. Because that's what you use for a solution set. Usually the braces are provided in ALEKS. I can't exactly remember if they are on this one. So that's part 1. And then the second part will be, what is the multiplicity at each solution? And each of these, I'll just write it out like this, have a multiplicity of 1. Because none of these were squared. If we factored and we had like a squared x plus 3, then we would have x equals negative 3 as a 0 with a multiplicity of 2. But here, these are all, to the first power, so we just have our 3 solutions, and they each have a multiplicity of 1. Number 6, we can take out a GCF. Our leading term is negative, so we want our GCF to be negative. That way we can factor what's left. All of my coefficients are even, so I can factor out a 2. I could factor a 4 out of the first and third terms, but 10 divided by 4 is not a whole number. So we factor out a negative 2, but they each have an x in them, so we'll factor out an x. Let's see what that leaves us with as we factor out our GCF. So I'm going to put my GCF out front, and then we have 2x squared minus 5x minus 12. And so we need to factor this trinomial, the A times C method. I'm looking for factors of negative 24 that combine into negative 5. So that's going to be 8 times 3. Since the 5 is negative, I want my 8 to be negative. So we're going to break up negative 5x into negative 8x plus 3x. So I'll do that down here, negative 8x plus 3x. And then I can bring down the other pieces of our trinomial. The GCF is just going to carry down into the next part. So here we can factor by grouping. On the right, bring down this sign. Out of 3x and negative 12, I can factor out a 3. Divide both terms by 3, and we get x minus 4. Over here, I can factor out a 2x, because both of these terms have an x. 2x squared divided by 2x squared divided by 2x is x. Negative 8x divided by 2x, the x's would cancel. Negative 8 divided by 2 is negative 4. And so what we have is our GCF times our x minus 4, we write once, and then the other pieces we factored out, the 2x plus 3. So again, I can tell from here that all of these factors have have an exponent of 1 on the exponents, an exponent of 1 on the variables. And so, let's solve over here, because we're set equal to 0. Negative 2x equals 0, that's always going to be 0. There's no number being added or subtracted, and so 0 divided by anything is just 0. So this is always going to be 0 unless it's a binomial. And then we have x minus 4 equals 0. That's just x equals 4. This one is 2 steps. The 2x plus 3 equals 0. Subtract 3 from both sides and divide by 2. So those are the solutions, which we call zeros in this chapter. That's where the graph would hit the x-axis at these 3 points. The leading coefficient, or the leading term, the exponent on that leading term will tell you how many solutions you should expect. Here we got 3 solutions, so they will all have a multiplicity of 1. So the zeros are 0, 4, and negative 3 over 2. And here they all have multiplicity, I'll abbreviate, of 1. Let's move on. Number 7. So for number 7, we have a GCF that we need to take out. Each of my terms have an x to the 4th in them. So we're going to factor out x to the 4th. Divide all of these by x to the 4th, and we're left with x squared plus 6x plus 9. This is a fun one. This is called a perfect square trinomial. This is what we complete the square. This is the form we try to get in as we complete the square. Like, forget about the 9. What if we just had x squared plus 6x? To complete the square, you take half of 6 and square it. And usually in class, we don't actually write down the squared version. We just have you write down 3 squared. But this is a perfect square trinomial. 3 squared is 9. You could also factor this like normal. The only way to get x squared is x times x. A plus sign here, a plus sign there, means 2 plus signs. My factors of 9 that combine into 6 are 3 and 3. Or it's that take half of 6 and square it. And then we have our GCF out front. So I have x plus 3 as a factor happening twice. You could also think about it as x to the 4th times x plus 3 squared. So now we get a solution of x equals negative 3, and that's happening twice. So we have x to the 4th equals 0, and x plus 3 squared equals 0. Here, you could take the fourth root. It's probably easier to understand on the x plus 3 squared. Here, we take the square root. You usually don't write the 2 when it's a square root, but the index of the root we're taking matches the exponent, so they cancel out, leaving us with just x plus 3 equals 0 as a solution. X equals negative 3. Here, you could take the fourth root of both sides. Any root you take of 0 is just 0. So those are the solutions. X equals 0, x equals negative 3. And maybe you want to write out these steps, maybe you don't. Eventually, if you do these enough, you'll see once you get to this step, if x to the fourth power equals 0, then I'm going to have x equals 0 with a multiplicity of 4. And then if I have x plus 3 squared equals 0, if x plus 3 is the factor, the solution is x equals negative 3. And that has a multiplicity of 2. And that makes sense because we started with an x to the 6th and a multiplicity of 4 plus a multiplicity of 2 gives us 6 solutions. 4 of those solutions are zeros, 2 of those solutions are negative 3. But 4 plus 2 gives us the 6. So let's keep that in mind as we look at number 8, because number 8 is factored. So I have negative 5x squared. Again, there's no number being added or subtracted. It's not a binomial. We just have a negative 5 as the coefficient. If we divided both sides by negative 5, 0 divided by anything is 0. So x squared equals 0 means we have x equals 0 happening 2 times. Multiplicity of 2. Then we have x plus 1 as a factor. If that were set equal to 0, we would get x equals negative 1. And this is happening once, 1 time. And then I have x plus 2 to the 4th power. Set the binomial equal to 0, and we get a solution of x equals negative 2 happening 4 times. And so 2 plus 1, an implied exponent of 1. 2 plus 1 plus 4 is 7, and that's what we have here. 2, 1 plus 4 equals 7. So it asks for these solutions and how many times each occurs. That's what multiplicity is. So here, multiplicities of these solutions. At 0, it has a multiplicity of 2. At negative 1, a multiplicity of 1. At negative 2, a multiplicity of 4. We'll look at our last 2 problems now. On number 9, if I factor out, well, let's look at it. So we have x to the 6th minus 5x to the 4th. We have a GCF of x to the 4th. So I have x to the 4th times x to the 6th divided by x to the 4th is x squared. Negative 5x to the 4th divided by x to the 4th is just minus 5. And so this gets a little bit tricky because this is not a difference of squares. The square root of 5 is 2 point something. I don't know. So x to the 4th equals 0. That's a solution of 0 with a multiplicity of 4. But what happens when we take x squared minus 5 and set it equal to 0? We would add the 5 to both sides, and then we take the square root. So be careful here. This was missed in the bonus points of the previous test. Let me write this out again. X squared equals 5. To get x by itself, we take the square root of both sides. But over here, it's plus or minus the square root of 5. So taking the square root makes the exponent of 2 go away. But if we're taking the square root of 5, it's plus or minus 5, root 5. Plus or minus root 5. So what are the solutions? We have a solution of 0, and we have a solution of positive root 5, and a solution of negative root 5. And then what are their multiplicities? 0 has a multiplicity of 4. And then the square roots each have multiplicities of 1. Alrighty. Finally, number 10. It's going to ask for a couple of things. Well, let's see. It's asking for the end behavior. So we only look at the leading term, x to the 5th. That's positive with the coefficient, and the exponent is odd. And so what happens when your function is positive and odd? That's the same as y equals x, because that's like x to the 1st, which is odd, and then the coefficient is an implied 1, which is positive. So anything that has a positive coefficient and an odd exponent, here's x to the 5th. Let's graph it. Oh, I forgot I zoomed in. Gotta wait for it to finish thinking. -10 to +10. So here's x to the 5th. It's going down to the left, up to the right. So again, I can't remember what how they asked for it specifically, but it's going down. Oh, I think that's how they asked. It's going down to the left, and it's going up to the right. And then to find the y-intercept in zeros, I'll work that out over here. Remember when we did graphing using the intercepts? If we're on the y-axis, then the x values are 0. So, in this case, p of x, whatever of x, f of x, g of x, it's the same as y if we're talking about graphing. So 0 to the 5th power minus 2 times 0 to the 4th. When you plug in zeros for the x, it just cancels those terms out. They become zeros. 0 to the 4th is 0. -2 times 0 is 0. So y equals 0. So when we plug in 0 for the x, we get 0 for the y. And that's what you'll get every time unless there's a constant being added or subtracted that has no x in it. And so the zeros, now we find these solutions by setting it equal to 0. X to the 5th minus 2x to the 4th. We could factor out in x to the 4th, leaving us with x minus 2. And so we set each factor containing a variable equal to 0. X to the 4th equals 0 means x equals 0 happening 4 times, multiplicity of 2. Take x minus 2, set it equal to 0, and we get x equals 2 happening 1 time. So these are the zeros. I don't remember if it asks for the multiplicity on number 10 or not, but if it does, there they are. And then the graph, you're just, I think you're picking from the graphs they show you. So again, we can just look at the graph itself. We have x to the 5th minus 2x to the 4th. So here you're just picking the graph that looks the closest. I think the things that might be different are, you'll have like, I think sometimes it's 6 graphs you choose from. Let me try to zoom in. Maybe turn off this light. I can't really tell if this is visible for y'all or not. But you can do it in your own calculator. So the things that might be different are like this little piece that dips down. It might not be there. Of course, make sure that the in behavior is right. It's going down to the left, up to the right. It has that 0, 0 that we identified as the y-intercept. And then, just pick the graph that looks the closest. So there's 7, 2. Hopefully that's a little clearer. If you have any questions on 7, 2, please reach out, and I will upload these now.